Christian Geis, welcome to Reinhard Baumfalk, and welcome Benjamin Beck once again. Before we charge ahead, let's just set the scene and take a look at sort of where we are at this time at the Hanover Messe 2025, because obviously, as we know, every year we meet here and things are moving so quickly. Where does the industry currently stand on the issues of sustainability and energy efficiency? Christian, let's start with you.
So where are we standing now? So I think we're doing a lot of efforts to increase our sustainability and energy efficiency, but on the other hand, one of our strengths is also a disadvantage. Our products have a long lifetime. So we have a lot of old products in the markets that are still running on, let's say, with state-of-the-art techniques, but we could, let's say, rework them, make them more efficient. So it's like kind of trade-off between long lifetime and sustainability, resource efficiency, and energy efficiency. And a lot of our products, I'm also responsible for hydraulics and only for pneumatics. So we have products running with pumps that are running with a constant rate and are not regulated. And we have systematic issues where we have like plants running on on too high pressure levels in pneumatics, because the compressor station will define the pressure level and not the product that might require less pressure. So I think we have a lot of, let's say, trigger points where we can act it. And I see we have a lot of efforts to do, but we also have a long way in front of us.
Mm-hmm.
Reinhard.
Maybe just to start with a more industry-wide perspective, just to add a few numbers. So what you can see, just now quoting a sustainability report from Deloitte from the last year, so more than 85% of industry leaders, the executives, have investment plans in place to invest in sustainability. So what you were targeting or describing from a technical perspective, it's also from an industry perspective already a matter of fact. Half of these companies have already programs in place. The other half is planning to do so for the next 2 years. So overall, for me, the statement would be industry has the tools, the scale, but also the innovative power in place to really drive sustainability and to make it even more important in future.
So I'm coming from Technische Universität Dresden, and we are doing research since decades now. But energy efficiency. I mean, we do research on energy efficiency since decades. But nowadays it gets a new vibe because electrification starts, and we see battery electric machines outside, especially in mobile machines. But energy efficiency is on vogue, so to say, also in research due to regulations and so on.
So absolutely bottom line, and a new vibe coming through the industry. Manufacturers, as we heard also from Christian, are facing an awful lot of competing priorities, and more they are prioritizing these issues as a competitive advantage. How are they successfully integrating sustainability into their strategies, and what real business benefits does it bring? Reinhard, let's start with you this time.
So first of all, it's important to see sustainability linked to business success. It can be even a smart business case. At the end of the day, so Benjamin, you were just referring to energy efficiency. It has an emission aspect, but it also has a business aspect. So energy savings
make the business case for it.
Is a business, absolutely. And if you just take the statistics into account, and we know numbers as well collected by the VDMA, the association, so as a company or industry-wide overview, over 90% of manufacturers have programs, strategies, activities in place. It's a widespread activity, so it's not just about one device, it's about getting components connected, it's about digitalization, it's about new technologies, so it's no longer just pneumatics, it's also connected then already to electricity, hybrid systems. All that comes in place, and it's a shared effort at the end of the day.
Mm-hmm.
I would like to add that we have to differentiate between the usage of a machine or a system and technical solutions. So we as engineers can provide technical solutions but have no or a little influence on the usage, how the operator is using the systems. But when we know how the operator is using the systems, we can optimize our components and systems for this special use case. And this is also a good benefit to link the usage with technical solutions.
Absolutely.
Christian, what have you got to add there?
I totally agree that it's really easy from a pneumatics point of view to adapt the application to the needs of the application, the operation of the application. But on the other hand, and it's also really easy to calculate it. So if you have a controlled pneumatics, for example, and then you can calculate the total cost of ownership, and with a smart solution that we already are able to offer, we'll push the break-even point into the future and be more and more competitive, or we are more competitive and are competitive with other technologies. On the other hand, I might be a little provocative, but are our customers always willing to pay the money for it? Because in the end, we or the companies as a component manufacturer, they offer solutions for a machine builder or for an OEM, and they want robust and cheap technology, and the energy costs are borne by the user in the end. So it's the problem is, let's say, the second stage. So we can offer, or we have really smart and really efficient and sustainable solutions, but it's again, we have sometimes let's say a collision of interests, maybe.
Benjamin?
I see it like Christian, and that's why we are doing collaborative research projects like Fluid 4.0, where we bring all or every stakeholder together to get this operator view, the OEM view, and the component manufacturer view together, because to optimize the energy usage and deliver a sustainable machine or product, we have to work together to put it all together and find a optimized solution, so to say.
Indeed.
And raise awareness, so the people must know that it's good for them to have the more expensive solution, because it will pay off in the future.
Yeah.
Well, that brings us to the question of the challenges, because obviously sustainability doesn't happen by accident. To bring everything to the next level requires, as you're implying and talking about strategic engineering. I'm just wondering if we can start with you, Christian. What are the biggest challenges in designing for energy efficiency, and how can system and component providers actually then support this?
Yeah, I think what Ben already said is we need to adapt the operation to the application. So that means we also need to be a little bit more confident. A lot of pneumatic designs are over-dimensioned because we want to make it robust and safe, but our drive does not need to last or operate for 30 years when it only is running for 15 years. So we need to be a little bit, let's say, proud of what we can do and be not over-dimensioning but adapting our products. And we need to raise awareness also to our users, that they know I can make a smaller or system operate at a different pressure level, and it will still have the productivity that I need. And so I think it's a lot about awareness, and it's also that we have to change mindset of our developers and our sales force at some point.
So I think we were talking about basically coordinating, obviously, all the players. Benjamin, your thoughts on sort of how what the biggest challenges are in terms of designing for energy efficiency. You're at the engineering stage.
We need data. That's a short answer. Because we want to...
Today's most valued currency.
Correct. And it helps to get on the right path. We need to decide what we do. And we want to optimize at this point where we get the most added value out of it. It doesn't make sense to optimize a component which is only 1% of the whole energy usage to get this in 1% efficiency better, because it has no impact. We have to analyze the process, therefore we have to measure and to rely on data, and based on data we can optimize the component or the system or the algorithm to really get an impact out of it and get the most out of it.
So the right data to be able to optimize the correct applications, obviously customer awareness of the levels of complexity and who all needs to be involved in these decisions. Reinhard, from the point of view of Emerson, where are you seeing the challenges?
We just heard that topic data, which is also a huge driver for us at Emerson. At the end of the day, it's a digital journey, not just only for us as a manufacturer, but for all our customers as well. At the end of the day, Ben, you just said it a minute ago, you need to have data about the whole system. That means the data needs to be generated. We need intelligent devices, we need components which are able to provide data, not just during operation, but also in advance, coming from a digital twin, for instance, to enable the customer to make the right choice, but also to get data during operations. We need to have connectivity. You need to be able to collect data in real time to have a view on and about the status of the machine itself, and then the end of the day you need algorithms to get a value out of data. Data per se is just the currency, it's not the business.
Food.
Exactly. And so this is the whole chain we are supporting, where we are offering also solutions to our customers, but where we also need to have cooperation with our competitors themselves. At the end of the day, it's a systematic approach. Sustainability, you can't handle it only from a systems level, and everyone has to contribute to that.
So a lot of collaboration required. Let's look quickly at the role of technology, because obviously every year we see a lot of improvements that are worth talking about. Every year the booth has a different constellation. For instance, something like fluid and control technologies are playing a key role in optimizing energy use. So what other innovations are actually helping industries to reduce this energy wasted while balancing cost and obviously performance?
Yeah. I like your title, fluid control, or that term, fluid control, because fluid, it's a decade-old or even century-old technology, seen often enough as as an old-fashioned one. I believe we have to rethink, we have to review, as we do it already in our cooperation, in our project Fluid 4.0, but also at Emerson, where we make fluidics intelligent. We make fluidics controllable. And that requires a lot of innovation, actually. So we have to understand better, so how do the components need to be designed? We need to understand better which data have to be provided. So it's from material sciences, where we need the input from academia about new opportunities, to data, digital strategies, down to understanding how a whole machine works or has to work in future from a sustainability aspect.
Christian, what other innovations can you tell us about?
I think the major issue and in the end the game changer is digitalization. So digitizing our products and digitalization of our processes and systems. And so we're talking about interfaces, we are talking about standards, we are talking about agreement across the whole branch that everybody follows the same approach. So we are compatible and interconnectable, and interconnectivity, we reach that goal. And this changed everything for Fluid Power and makes us ready for the future. So now we have more data, we heard we need data. We have more information about the application, so we can adapt and optimize. And this is a big game changer from my perspective. And I can only invite you all to go to Hall 5, because in Hall 5 we have the special show Fluid Power 4.0, and we show a lot of use cases all along the product life cycle. And it's all about digitalization and sustainability and getting smarter and better.
Thanks very much, Christian. Benjamin.
I mean, it's not data over everything. As I said before, it's only the first step. We have to analyze it, therefore we have to measure and generate data, then we have to transform it. But to be honest, then our work as Fluid Power engineers starts really, because then we have to optimize the component or the system based on this data. And therefore we do have solutions in research and the industry to set up new system structures, like for example in pneumatics. I mean, the biggest point is the compressed air. Air has big compressibility, as you may know, and it costs really much money to compress the air. And what are we doing nowadays? We let the pressurized air flow through a valve to the cylinder and then blow it out in the air. And don't reuse it. I mean, one solution is to reuse the exhaust air in pneumatic systems. And these are the little points we get clear through data and see it like, oh man, was I blind? It's so easy, and it's, we can find an easy solution to reuse this air and do have an energy optimized and sustainable system.
Anything else to add, Reinhard, on the innovation front before we come to the bonus topic of AI? You talked about further innovation, but we'll get to AI in a second. I'm just wondering about the other, I mean, component design, various other innovations that are helping to prevent, bring down costs and increase performance.
AI definitely plays also here a major role, and it's a rising star also in the fluidics. Maybe just coming back to your statement before, so one rule of thumb, just to make clear what we're talking about, if we enable our customers to lower his compressed air level by 1 bar, it's 10% savings in costs of the operational cost for his machine. So it's not just, you mentioned it, it's a costly energy source, so we really can help here our customers. But coming back to AI, how do we get there? So it's, again, digitalization. So as soon as we have data available, we can start to build the model to understand how the machine itself, the status of the machine is working, and we can help optimizing it by algorithms, machine learning to bring that into the game. And also here, just an example, we recently had a project together with a customer, a global manufacturer of consumer goods. We were able to reduce his usage of compressed air by 20%. We're able to roll that out on more than 30 sites, and within less than a year, he had the return of investment. So again, sustainability in business is very closely connected, and AI is helping here in bringing, in particular, this not easy to handle media, so fluidics, whether hydraulics, compressed air, it can be nasty. AI helps a lot to handle that much more efficiently.
Benjamin, so your thoughts on at which point AI is absolutely revolutionizing things. Obviously, it's a long process of digitalization that has been going on for years. Clients are incrementally switching over their systems. How does it look from your point of view?
It has two aspects. First, we can use AI to help in our engineering processes to find a. We're talking several minutes about optimization.
Yeah.
We need, AI helps us by optimizing the component or the system. And to be honest, I was yesterday here at Amazon and did see already a good solution for your leakage detection on the valve system there, the failure detection system. AI is in it because it's really complicated to find an physical based, or we call it in research white box or gray box based model based approach to detect which valve in the system does have which leakage.
Yeah.
And there are the context is too complex between the data and the identification which valve is the faulty one. And therefore, AI helps to analyze the informations in the usage. I think you have a volume sensor in it and the signals to the valves. And I mean, it's already 10 signals or something like that. And it's hard for to find an algorithm or define the algorithm to do the fault identification. And AI can do it easily in a minute.
So AI in the system design, but also in the process itself.
Totally, that's the message. To help the engineers find easily and quickly a good solution, and in the usage phase to get complex context easy together.
And if I understand correctly, and we'll hear more about that in the second panel where we'll be focusing on AI, obviously, but it's helping to even identify gray zones that one hadn't even identified before. Yeah. Christian, your thoughts on the potential of AI? for these processes?
We talked a lot about techniques, but we also need to talk about business cases. So
Yeah.
digitalization, for example, will open a lot of business cases in condition monitoring, fault detection, service, predictive maintenance, whatever, so that we can improve. And AI, of course, will open up a multitude of possibilities for us, because and we don't know, we cannot know yet what it will do, because that it's a transformation of our industry, and so in the end, I think we will have large language models that will help us in service, in design, in everything, and we have also might have small language models on our components itself, and we'll find correlations of data. We'll have smart data and smart sensoring possibilities that we never thought about, and so it will put us on a next level. I'm really sure on that, but I cannot make any prediction how it really will look like, because before the first iPhone, everybody thought that the Nokia was state of the art. So and then we suddenly had a smartphone that has changed everything, and I think that the AI will do the same with us.
Predicting business cases is obviously always difficult, but predictive maintenance is something else that is very much sort of in hand at the moment.
Yeah.
Anything to add on AI and the potential of it for these processes before we open up to the floor, Reinhard?
Yeah, absolutely. So predictive maintenance, AI, it's about, again, modeling. So AI helps to combine the data we get from the different areas out of a machine, and to understand how the maintenance or the condition monitoring status of the device itself is, and to helps to make an early assessment on, is it changing, is there a need for maintenance coming. So we with AI we have totally different tools and much better tools in our hands to reinvent predictive maintenance. Absolutely. And what I would also like to add to what you said before, Christian, AI will help really bring in sustainability from design on. So you have been referring to engineering tools, life cycle assessment, and one of the standard tools in the future for engineers when they design a product will help a lot in really bring sustainability in already from the beginning, so that we not only talk about maintenance but also design and sustainability.
Benjamin.
At this point, I would like really to add one point, which is the limit of AI. I mean, maybe
The limits of AI.
The limits of AI.
Okay.
Can we go a little bit deeper?
Absolutely.
into
Let's
the
go a little
techniques?
bit deeper.
I like it.
Yeah.
Because AI is always as good as the trained data. Yeah. If you ever work with AI,
We will be speaking about modeling in the next panel,
Okay.
but please go ahead.
perfect. Then just shortly,
This is one of the challenges
we need
for
data
customers.
we need data for AI. We said it. That's why we collect it, interchange it in interoperable formats, and bring all the players together in research projects like Fluid 4.0. And then we can use AI, but only for this what it's trained for. Yeah, we have really maybe in beforehand look what we want to do,
Yeah.
what AI should do, and then we collect the correct data for this use case.
So thanks very much to Benjamin Beck for basically pointing out the limitations and where things have to go, but and endless potential, I think, as well, once everybody's properly involved. Let's open up to the floor. I think this is a good time to open up if there are questions. Are there questions from any of the journalists here to any of our panelists? Benjamin Beck from the TU Dresden, Christian Geis from VDMA Fluid Technology, or Reinhard Baumfalk from Emerson. Any hands going up?
Benjamin, you said we need data for sustainability and for energy efficiency. So which aspects of data security need to be taken into account?
Yeah, it depends on the partners who are involved and on the way you transmit the data from between the partners. But if you do it wirelessly, we are directly into the security topic. And yeah, we have to find good solutions to find a secure way to transmit it. But technologically, it's solved. We do have authentication, we do have encryption solutions, we can securely transmit data from one to another.
Yeah.
If this was the question.
And is it a part of your floor to cloud strategy, or is it implemented?
No, absolutely. So first of all, we are aware of the legal requirements, the regulations we have in place. Cybersecurity Act needs to be mentioned here, but we are ready or have it implemented and have it part of our strategy since a while. At the end of the day, that we have seen that already in the past as one of the limiting factors of digitalization in the industry, so that customers, that manufacturers were hesitating to use it because of the risk. So since a number of years already, we have it as an essential part, as kind of risk management. Cybersecurity is a more recent one now, adding to that, to have that in our flow to cloud strategy. Absolutely.
And maybe to add one thing, we do have also good open source solutions, which are really, I think, suggested from the BSI, from the German Security Institute, so to say. And yeah, I mean, technologically it's solved, and in our Fluid 4.0 project, we are addressing these issues too, to use secure channels to transmit data. And we are always defining what information is public, and for what information we need a contract or something like that to interchange the informations between, let's say, an operator and an OEM.
There is no digitalization without the question of cybersecurity. So we need it on every level. So we need to protect data. For example, if we talk about the asset administration shell, there is a specification part 4. It's about security of the data. If we speak about transfer, we need to use secure formats and protocols. And I think we all need to address this, and we do that. So.
Just to add the last one, we even have solutions for local AI systems. When you look to the actual development of the AI things, I mean, it's really fast. You can read every day good AI news. But with DeepSeek, we have, I think, firstly, the possibility to run local AI systems on your own resources. Yeah? And that's a big game changer for security aspects, because you don't bring your chat data into a cloud elsewhere.
Yeah, so Edge AI definitely makes a difference to have it implemented. This creates per se a secure shell so that you have it all integrated. But then we come back to what you mentioned earlier. So how reliable is AI already? So it can be an internal safety risk, less a security, but a safety risk to have a non-reliable piece of software inside the machine. So we talk about trustworthy AI a lot, where we also see already standards coming up, how that can be then integrated in industrial applications. So we all don't care if Gen AI hallucinates and creates funny statements about what we have asked, but it's a different story if it's a machine doing strange things at the end of the day.
Thanks very much for that question. Did you have another one, or does anyone else have a question for our panelists? Thanks very much for pointing out the point about data security, and obviously AI needs the right data and system we've talked about it at system design level, but also at operations level, and how it actually will be driving this drive towards energy security and energy efficiency. Before we close this panel, if there are no other questions, I'd love to just get a key takeaway from each one of you. And perhaps, Christian, I can start with you. What is the most important step that industry players should be taking today to improve their footprint? We get back to this whole starting idea of sustainability. So with regard to sustainability and energy efficiency, what steps should players be making today that they haven't made already?
I think I said it before, there are conflicts of interests, and in the end, I think it's about communication. You need to communication across the whole product life cycle, the component manufacturer with the OEM, with the end user. And the more they communicate and the more they agree on technical solution, and the more they can do regarding efficiency and sustainability. And let's say circular economy as well. So and in the end, we need to raise awareness we need to agree on the same standards and we need to communicate.
Raising awareness among customers. Reinhard.
I would like to highlight one slogan of Emerson. We have it there in the right corner. So
Slogan of Emerson.
Drive sustainable growth. So what I see as really the key changer is that it's no longer just a topic on its own, but it has sustainability has found its way into the strategies of the companies, into the business cases, also being a part of cooperation between industry or companies, really being an important topic in the industry itself. So sustainable growth, this is to me the message. So we managed to turn that into a business case.
Absolutely, a business case that is proving itself time and again. Yeah. Benjamin, your advice for the first step that industry players should be taking on this drive towards sustainable growth.
My admit would be something I've never mentioned before in our talk here. I would really give the advice to develop model-based, because model-based is really a good technique based on data to find optimized solutions. We were talking about optimized solutions, and model-based development can help to quickly and easily find a good solution.
Model-based development is something I think we'll be talking about models and the challenges that customers are facing with regard to that in the next panel on AI. But for now, if there are no further questions from the floor, I would like to thank all of our panelists. Reinhard Baumfalk, thanks very much again for being here with us this year. And Christian Geis from VDMA Fluid Technology, thank you very much for your insights on this panel. And Benjamin Beck, representing Fluid 4.0 from the TU Dresden, and obviously looking to see that the right data gets put in the right places and developing those systems. Thank you very much for your insights here today and for joining us.
Thank you.